In Module 2, and expressions and work more with additive and multiplicative inverses. Additive inverses have a sum of 0. Multiplicative inverses have a product of 1. We're going to fill in the center column of the table with the opposite of the given number or expression, and then we're going to show proof that they are opposites. So the first one is started. If we have 1, the opposite of 1 is negative 1. And our proof that it's opposite is we add them together. 1 plus negative 1 equals 0. Additive inverses have a sum of 0. So our next number is 3. The opposite of 3 is negative 3. And our proof that it's the opposite is we'll add 3 plus negative 3, and that equals 0. Our next term is negative 7. The opposite of negative 7 is 7. And we'll prove it by saying negative 7 plus 7 equals 0. Next term, negative 1 half. The opposite of negative 1 half is 1 half. And we'll add them together. And they equal 0. And now we'll look at algebraic terms. The opposite of x is negative x. And when we add x plus negative x, we get 0, no matter what the value of x is. So the opposite of 3x would be negative 3x. And if we add them together, 3x plus negative 3x would cancel each other and give us 0. Now we have x plus 3. The opposite of x plus 3 has to be the opposite of both terms, which means we would have a negative x plus negative 3. Now to prove that they are opposites, we're going to do x plus 3 plus negative x plus negative 3. And the x and the negative x cancel each other and make 0. And the 3 and the negative 3 cancel each other and make 0. And 0 plus 0 is 0. Just to prove that one more time, since this is all addition, let's change the order of our terms. So we can do x plus negative x, we'll group those together. And then 3 plus negative 3, group those together. And it's easier to see that x plus negative x is 0, and 3 plus negative 3 is 0, giving us 0. And then our final term, we have 3x minus 7. Again, its opposite has to be the opposite of both terms. So we would do negative 3x plus 7. And to prove that they're opposites, let's add them together. And let's rewrite this subtraction as addition, just to prove that. We have 3x plus negative 7 3x plus 7. And now we have all additions, so we can change the order any way we'd like. And we're going to take the x terms and put them together. 3x plus negative 3x. And then let's put our number terms together. Negative 7 plus 7. And then it's much easier to see. We can even use the associative property to group these together. Go ahead and do that so we see the grouping. We have 3x plus negative 3x, which is 0. Negative 7 plus 7, which is 0. And 0 plus 0 is 0. Next, we're going to look at a numerical expression and show two different ways that the opposite of a sum is the sum of its opposites. So we're going to do this. 40 plus 9. And then our subtraction tells us that we have to do the opposite of this sum. And that means that we are going to add the opposite of each term. So the opposite of 30, which is negative 30, and the opposite of 2, which is negative 2. Now when we do that, I'm just going to do some simple addition now, and we can add in any order. In this instance, I'm going to rewrite it as 40 plus negative 30, because those are easier to combine, plus 9 plus negative 2. And that'll give us 10 plus 7 if we group them together. Put some grouping symbols in here for the associative property. Any order, any grouping, remember, because it's all addition. And 10 plus 7 equals 17. Now, for all of us, solving a numerical expression is oftentimes easier to just solve what's inside the parentheses using the order of operations. So that's what we will do next. We're going to actually solve using the order of operations to prove what we just did, which was to change the subtraction to addition of its opposites. 40 plus 9 is 49, and 30 plus 2 is 32, and 49 minus 32 is 17. Yes, this is much faster, but of course, when we have variables in our expressions, we can't solve what's inside the parentheses because we don't know what x and y are. That's why this property is very important. So now let's follow the same principle with this expression. 3x plus 5y minus 4. And we're going to subtract 4x plus 11. Now let's go ahead and rewrite it all as addition first. So we're going to have 3x plus 5y plus negative 4. Subtracting 4 is the same as adding negative 4. Then we're going to change this to addition, but we'll have to take the opposite of each term inside the parentheses as well. So we're going to add, and 4x would be negative 4x, and the opposite of 11 would be negative 11. From there, we can combine like terms, and let's go ahead and move the x terms close to each other. 3x plus negative 4x. There's only one y term, so we'll just write it there, plus 5y. And then we'll have the numbers next to each other. Those are called constants. And then grouping them together, because remember, this is all addition now. So any terms that are the same, we can group together so it'll be easier to see what we're combining. 3x plus negative 4x is negative 1x, or negative x. 5y won't change because there isn't anything to combine it with. And negative 4 plus negative 11 is negative 15. And that is the simplified version. We could write this a different way, just so you know what you might see. Negative 1x is the same as negative x. Negative 1 times x is negative x. Plus 5y, which doesn't change. And adding negative 15 is the same as subtracting 15. So you might see this expression written this way as well. In example 2, they're asking us to combine the expressions vertically, and all they're really asking us to do is line them up and down, instead of horizontally across. It's a visual thing. You might be able to see how they're combining a little bit better when they're aligned with each other. I still highly suggest that you rewrite all of the subtraction as addition. Which means we would have to change But once we line those up vertically, we can see 5a plus 2a is 7a. And then 3a plus negative 4b is negative 1b, or negative b. Negative 6c plus 13c is 7c, positive 7c. And so our combining gives us 7a plus negative b plus 7c, which we could rewrite as 7a minus b plus 7c. And we'll do that one more time with the next expression, 2x plus 3y minus 4. Now, I'm just going to rewrite all of this. 2x plus 3y, and we'll rewrite it as addition plus negative 4. And then we're going to be subtracting 5x plus 2. So we'll have to change this to subtraction and change the sign of each of those terms. So then what we want to do is negative 5x and we're going to be adding a negative 2. But the -2 won't combine with the y term. It's not the same as the y term. So we'll have to put it underneath the other constant, which is -4. So you have to be careful when you're doing your work vertically that you line up the terms. 2x plus -5x is -3x. The y term won't change because there's nothing else to combine it with. And then -4 plus -2 is -6. Just so we can see, I'll rewrite this as -3x plus 3y. Remember, you cannot combine these two terms because x and y don't stand for the same thing. And then instead of writing plus -6, we could write -6. Example 3 is a real-world problem. They tell us a stick is x meters long, and a string is 4 times as long as the stick. So first we need to express the length of the string in terms of x. And the string then would be 4 times x, because the string is 4 times as long as the stick, and the stick is x. So the string is 4 times x. Then in part B it says, if the total length of the string and the stick is 15 meters long, how long is the string? This is an interesting situation because if we had labeled a little better up here, if we had said the stick equals x, and then we said the string equals 4x, then this would have been a lot easier to set up. Okay, so we'll show that. The total length of the string and the stick is 15 meters long. The total would require us to add. So x plus 4x equals 15. Now we can solve this equation. 4x plus 4x is 5x. 5x equals 15. So that would mean that x must equal 3. We divide 15 by 5, x equals 3. But we didn't answer the question, how long is the string yet? We know that x, which is the length of the stick, is 3 meters. But the string is 4 times that length. So the string is 12 meters. 4 times 3, 12 meters long. An example 4 are expressions from word problems. It costs Margot a processing fee of $3 to rent a storage unit, plus $17 per month to keep her belongings in the unit. And her friend Carissa wants to store a box of her belongings in Margot's storage unit, tells her that she will pay her $1 toward the processing fee and $3 for every month that she keeps the box in storage. We'll need to write an expression that represents how much Margot will have to pay for the storage unit if Carissa contributes, and then determine how much Margot will pay if she uses the storage unit for 6 months. All right, first, we need to write our terms and label everything. So we have the PS, the processing fee, which is $3. And then we have the rent, is $17 times the number of months that we're keeping things in the unit. Okay, this is your basic fee. Now, Carissa is willing to pay her pay $1 toward the processing fee, and then she will pay $3 for every month. So 3 times n, which keeps the box in storage. We're going to write an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes, and then determine how much Margot will pay if she uses the storage unit for 6 months. And that is, of course, assuming that Carissa is also going to contribute. So, first of all, our expression, which is 3 plus 17n. And it's easy to put together if we write and label everything first. So the processing fee plus $17 per month, that is how much is going to have to be paid for the unit. Okay? If Carissa contributes, Carissa is going to pay 1 for the processing fee plus $3 a month. So we can solve this expression first to tell us how much Margot will have to pay for the storage unit if Carissa contributes. And we'll do that the same way we've been working on these. 3 plus 17m. I'm going to change that subtraction to addition. And each of those terms will have to be the opposite. So negative 1 plus negative 3m. And then we can regroup the 3 plus the negative 1 and the 17m plus the negative 3m. Group those together. And that'll give us 3 plus negative 1, which is 2. Plus 17m plus negative 3m, which is 14m. So if Carissa contributes, Margot will only have to pay $2 plus $14 a month. Now, if Margot uses the storage unit for 6 months, that would be 2, I'll substitute in, 2 plus 14 times 6, that's the number of months. And using the order of operations, we'll do 2 plus 14 times 6, which is 84. And so Margot will have to pay $86 if Carissa contributes.
Finally, in example 5, we're going to extending the use of the inverse to division. So we're going to look at multiplicative inverses and then prove that their product is 1. And finally, we're going to use the inverse to write a corresponding expression in standard form. So the first one is completed for us. They're giving us 3. The multiplicative inverse of 3 is 1/3. And we prove that by multiplying 3 times 1/3. And they rewrote 3 as an improper fraction, as 3 over 1. You multiply 3 times 1, which is 3, 1 times 3, which is 3, and 3 over 3 is 1. And remember, the number and its multiplicative inverse have a product of 1, positive 1. Then they put that inverse into a standard problem. The first number is randomly chosen. So we're doing 12 divided by 3, that's the given number, and we change that to multiplication of the inverse, 12 times 1/3, which is 4. Following the same pattern, the multiplicative inverse of 5 is 1/5. Proof, we would do 5 times 1/5 and we'll rewrite 5 as an improper fraction, 5/1 times 1/5, which equals 5/5, which is 1. Then I'll choose 15 as our given number, and if we divide 15 by 5, so we have 15 divided by 5, we change that to 15 times the reciprocal, which is 1/5, and that equals 3. Next term is -2. The multiplicative inverse would be -1/2. In our proof, -2 times -1/2 would be -2/1 times -1/2, and -2 times, well, negative times a negative is a positive, and 2 times 1 is 2, 1 times 2 is 2. Which proves. And I chose 18 for the given number, divided by -2. We rewrite that as multiplication of the inverse. So 18 times -1/2, and that would give us 18 times -1 times 1/2. We can split that negative out of there, giving us -9. Our next term is -3/5. The multiplicative inverse would be -5/3. We simply keep the sign and flip the fraction. In our proof, we have -3/5 times -5/3. The negative times the negative makes a positive. And 3 times 5, 5 times 3 are both 15. And for our expression, I chose 6 as the given number, divided by -3/5. We change that to multiplication of the inverse, which is 6 times -5/3. And that would give us -30/3, which is -10. Our last two terms are algebraic expressions. And so the multiplicative inverse of x would be 1/x. And when we multiply x times 1/x, we get x/x, which is 1. Any number divided by itself is 1. For our example, I chose 5x as the original term. We're dividing by x. So we change that to 5x times 1/x. And since it's all multiplication, 5 times x times 1/x, we can multiply the x times 1/x, which gives us 1, and 5 times 1 is 5. This is a very important concept. Make sure you look at it and you review how that's done. And our final example then is 2x. The multiplicative inverse is 1 over 2x. Our proof, 2x times 1 over 2x, we can split these into all of their different factors. We have 2 times x times 1/2 times 1 over x. And then we can, because it's all multiplication, any order, any grouping, we can group 2 times 1/2 and x times 1 over x, and that'll give us 1 times 1 equals 1. And then for the proof, it shows 12x as the original term, and we're dividing by 2x. We change that to the multiplicative inverse, 12x times 1 over 2x. And then since this is all multiplication, 12 over 1 times x over 1 times 1/2 times 1 over x. And if we, any order, any grouping, if we move them around, we would do 12 over 1 times 1/2, which is 6, and x over 1 times 1 over x, which is 1. 6 times 1 is 6. So we can rewrite subtraction as adding the opposite before using any order, any grouping, and we can rewrite division as multiplying by the reciprocal before using any order, any grouping. Remember, you have to change the subtraction and the division to addition or multiplication before you can use any order or any grouping. You can't move things around until you've done that. And of course, the opposite of a sum is the sum of its opposites. We proved that a number of times. Just follow the same guidelines that we've been working on in these past 2 lessons, and solving your expressions and equations should be much easier.